Hey Rocco. Alright, so we are already on lesson 9 of module 3. For this lesson, there is an opening exercise, so please make sure you do that before you watch the rest of this video. If you need to pause right now and do that, please go ahead and pause. Otherwise, I'm just going to keep going. I'll start with example number 1. Alright, so Fred and Sam are a team in the local 138.2 mile bike run-a-thon. Bike run-a-thon, also known as a duathlon. Man, that's a lot of biking and running. This is a real thing. I know people who do this for fun. I cannot imagine biking and running 138.2 miles. You do kind of get to do, sometimes they'll split it up. Let's see what they do in this one. So Fred will compete in the bike race and Sam will compete in the run. Okay, so it's kind of like a relay. Fred does part of it and then Sam does the rest. So Fred bikes at an average speed of 8 miles per hour and Sam runs at an average speed of 4 miles per hour. Wow. That's pretty fast, especially considering how long they have to keep that pace. All right, so the bike race begins at 6 a.m., followed by the run. Sam predicts he will finish the run at 2:33 a.m. the next morning. I told you, gotta be kind of insane to do this, right? But it's the good kind of insane. You wrote a whole essay about how important it is to run. Here we are. Sam's doing it. All right, so how many hours will it take them to complete the entire bike run-a-thon, so the entire duathlon? From 6 a.m. to 2 a.m., the following day is 20 hours. I know that. I can do that math. So, what we need to figure out, 33 minutes in hours, right? Because he says 2:33. 33 minutes would be 33 over 60, which is the equivalent of 11/20. That's right. So then we could take that, put that as a decimal. Well, let's make it over 100. Make it over 100. That's 55 over 100. So we can say, okay, the decimal for that is 0.55. Right? Or 0.55 hours. So they're thinking here, right now, the prediction at least, if Sam finishes when he says he's going to finish, their prediction is that it's going to take them 20 hours, 0.55 hours. 20.55 hours. A little over 20 and a half hours of biking and running. Okay, so let's look at this though, because that's the prediction. Let's see. If T is how long it takes Fred to complete the bike race in hours, write an expression to find Fred's total distance. So D, the distance, would equal his rate times the time he takes. Distance is rate times time. We know that. That's a formula that we can use every time we do this. Any kind of thing like this is distance equals rate times time. That's a formula to memorize. And it's not because I'm going to give you a test, but it's because it's going to show up in so many problems from here on until the infinity of the end of being done with math, and then some, because guess what? Anytime you're trying to figure out how far it is to drive or how long you've been driving or any of that, this will come in handy. This is seriously probably one of those pieces of math people use all the time. And that's one of the reasons people always get frustrated with Google Maps, or they're like, yeah, I beat the system. Yeah, because you had a different rate. That rate there. Or, oh man, I thought I was going to be there in time, but I didn't. Well, yeah, time the distance. You added some distance because you took the wrong route. Guess what? Either the rate or the time are going to have to change to keep these equal. This is seriously math that you will use probably the rest of your life. Honestly, until you're old and no longer driving. And yeah, I know you're not even driving yet. But until you're old and not driving, you will be using this math forever. So it is an important thing to learn. Distance equals rate times time. Okay, so going back to that though, because distance equals rate times time, right? The expression of Fred's total distance is, well, distance equals, we know his rate, don't we? Yeah, 8 miles per hour. 8 times time. We know that. So now, let's see, write the expression in terms of t to write, or to express Sam's time. So this is Fred's time right there. I'm going to take my green marker to do Sam's. Sam's distance equals rate times time. Sam's distance equals, what's his rate? Oh, his rate is 4 miles per hour. Oh, he's running, so he goes a little bit slower. So 4t. D equals 4t. 4 times t. Okay, so great. Now we need to figure out an expression in terms of t that represents Sam's total distance. Okay. Oh, sorry. Yeah. Let's look at that again. An expression in terms of t to express Sam's time. Since t is Fred's time and 20.55, sorry, 20.55. So let me try Sam's again, because Sam's is going to be a little bit different. Sam's, I should have looked at this a little bit more, sorry. So Sam's would be that 20.55 minus t, because t already, we know, t was the time that Fred takes. So the 20.55 that we figured out back here minus the amount of time Fred takes. Okay, that makes a little bit more sense. Sorry, that was C. Let's go to D. So write an expression in terms of t that represents Sam's total distance. So Sam's total distance is going to be D equals 4, right? That rate that Sam uses. Sorry, I should be using green. D equals 4 times, and then 2.55 minus t. Okay? So 4 is the rate, and then this is the amount of time he's going to do. Okay. So now we need to write, oh, great. So we can also try to shorten this a little bit. So I can multiply this out. So D equals, well, 4 times 20 and 55 hundredths. Multiply that out. You're going to get 82.2 minus 4t. That's going to be a simplified version. Okay? Okay, so we've got those. Now we need to look at the next part, E. Write and solve an equation using the total distance both Fred and Sam will travel. Okay. So we're going to use what we've got. Actually, I should be using this board, huh? So here we're going to start out with our 8t, right? That was Fred's, plus 4 times 20.55 minus t equals Oh, we know how long the race is, don't we? It's 138.2 miles. How handy is that going to be? All right, so we just need to figure out how much time it actually takes them. So let's simplify this first. So we already knew that simplified part for Sam. So 8t plus, this was 80.2 minus 4t, like that, equals 138.2. Just like that, okay? Remember, you can pause the video if you need to write these things down. Okay, so now we're going to try just reordering it so it makes a little bit more sense. So 8t minus 4t plus, sorry, I'm going to make those kind of curved t's so that they're clear, plus 80.2 equals 138.2. Okay, so now we need to shorten it out even more. 8t minus 4t. 8t minus 4t is going to give me 4t, right? Because 8 minus 4 is 4, so 8t minus 4t would be 4t. Okay, so 4t plus 80.2 equals 138.2. So far, all we've done is rewrite this in a simpler way, right? Well, now I'm going to rewrite it some more to actually start solving. So I'm going to do the same thing on both sides of the equal sign so that I am able to get to 0 on one side and end up with something we can use to solve. We can do it the same thing on both sides because it doesn't change the equivalence, right? Adding 1 to each side doesn't change the fact that they're equal. Kind of like if you and Mario, right? You and your brother both had 3 pieces of pizza, and your mom comes over and is like, here, you each get 1 more piece. You both still have the same amount, even though you added 1 more. You have the same amount as each other. And so that's kind of what we're doing. We are making it equal between both sides, even though we're changing a little bit on each. So we're changing it by the same amount, right? Here we're going to actually be subtracting the same amount on both sides. So it's kind of more like you were each given 3 pieces of pizza, and then your mom goes, wait, Gianna needs some, and comes over and takes a piece from each of you so that it's equal, right? You'll still be kind of annoyed that you just lost out on a piece of pizza, but you have the same amount as Mario, and that stays equal. Okay, let's go ahead and start doing that. So 4t, I'm just going to rewrite this on my board so that we've got it. 4t minus 80.2 equals 138.2. So what we're going to do first, we're going to subtract this 80.2 from each side of that equal sign, right? So 4t minus 80.2, I should say plus 80.2 minus 80.2. We're going to add it on each side. So, because we're adding on each side, nope, that was supposed to be a plus sign. That makes more sense. So plus, we're going to be subtracting on each side. This is why it's really important that you rewrite it correctly, because I had rewritten it incorrectly. That's an addition sign. All right, so we've got our addition sign. We're subtracting 80.2 on each side. So 138.2 minus 80.2. Okay. Now we're going to actually do that subtraction. So subtract 80.2 on each side. Well, over here, 4t minus 80, or plus 80.2 plus, or minus 80.2, that's going to be 0. So 4t minus 0 equals, then we need to do 138.2 minus 80.2, which we end up with 56. Okay, we can rewrite this without that minus 0. 4t equals 56. Okay, so now we're just going to multiply on both sides. Keep it equal. So to try to get just 1t, I'm going to multiply by 1/4. 1/4 times 4t equals 1/4 times 56. 1/4 times 4 would equals 1. So 1/4 times 4t would give us just 1t. And 1/4 times 56, that's 14. Whew. Okay, so we just figured out, right here, we figured out that Fred's time, oh, losing my board. All right, so I'm gonna erase this. We just figured out Fred's time. Because remember, t was Fred's time. T equals 14, so Fred takes 14 hours. Fred takes 14 hours to do that biking, and that leaves Sam. Yeah, so Sam is left. Maybe I should be doing it like that, so it's labeling. All right, so Sam's time. Sam's time, we know, is going to be 20.55 minus 14. Right, because we knew 20.55 minus t was his time. So 20.55 minus 14 gives us 6.55 hours. Sam's prediction is that he's going to run all of that in 6.55 hours. Sam and Fred are crazy athletes, and you, my friend, are a crazy mathlete. I'm going to leave you with this right now, with just example 1, because that was so much math, and I realized after the last lesson that I might be overwhelming you. So, we're just going to do one exercise or one example at a time, just like we do usually in class, because we can take our time. We're doing such hard math, and you're already going so far advanced that I don't mind slowing it down to make sure that it makes sense. So right now, you should have all of what we just did written down, otherwise go back and write it down. But if you had any questions while you were doing that and they didn't get answered by me, please email me and let me know your questions. Ask your family, your older brother, someone in the house that might be able to help you. But for sure, your teacher whose job it is to teach you this lesson is right here, ready to answer your questions, okay? So please let me know if you need any help, okay? I'll see you next time.